Hi, welcome back. In this video you will learn how to use the Pathlib library. Pathlib is a standard Python library, so it comes shipped with Python. You don't have to install Pathlib, it is installed by default. And Pathlib first came in Python version 3.4. And it is often seen as a substitute of the OS library. So both OS and Pathlib are used for file and directory operations with Python. But OS treats file paths as strings, and Pathlib uses a path object type to represent paths. So file paths, text files, CSV, etc. You'll see in more detail what Pathlib does and how you use it to operate files and folders in Python. So let's begin. In this REPL here, I have this empty Python file and I have this folder named files. And the files folder has two text files inside, abc.txt with some sample contents and def.txt with some other text inside. Now, before Pathlib, file paths used to be treated as strings. Let's say if you want to read this abc.txt file, to read the content of that file, first you'd have to think about the path of that file, which in our case it's files/abc.txt, and then you'd say with open p1 in read mode as file and say print file.read. Right, and we get the outputs correctly when we run the script. So content1 is the text inside ABC. So you can do this, you can still do this. However, now with Pathlib, it is recommended to use a path object type, which comes from Pathlib. Import path. So that is a class, path. And what you do with that class is you instantiate it. So path, inside brackets or parentheses, you put a string which represents a path to a file, right? Now, if I print out P1, you're going to see that it looks the same as this, right? So it looks like a string. However, it is not a string. If you print out the type of P1, you're going to see that it is a POSIX path type. So that class produces these types of objects. And so what's the benefit of paths? You could ask, why not using just strings? Why complicating the code like that? Well, the benefits of the path class are not visible in this small example, but if your code expands, so for example, you'll see now how path comes in handy. If we say if P1, so P1 is this file path, exists. So exists is a method of this kind of object. You can check more methods by doing dir. After importing path, you can do dir path. And so you'll see that exists is here, the method I'm using now. And you have more methods as well. So let's use exist. So if the path exists, then we execute this code. Right. So run. And yeah, we got the same output because the path exists, so we got the reading correctly. So this file existed, but you could also create paths for non-existing files. What I mean by that? Let's say you want to create a new file. Let's call this ghi.txt. So you create the path of the file, even though the file doesn't exist physically on disk. We create it in Python, and then we can write something, so change R with W to open the file for writing, and then here we say file.write contents3. So this code here will be executed if p1 exists, but we could say something like if not p1 exists, then create that file. And Python creates it. So you see GHI content3. So I hope that the benefits of using path is now more obvious. So what I'm trying to say is that you have many methods and properties that you can use to manipulate paths. In this case, we used exists. Let me show you another benefit. So because P1 is a specialized path object, it has capabilities, for example, to extract the name of the file only. So if you print this out, print p1.name, you're going to get only the file name, which could be useful in different scenarios, and you'll see how this comes very useful when you do things like renaming files, deleting, etc. So p1.name gives you the file name. If you want to get p1.stem, guess what this returns? Well, it's only the file name without the extension. And of course, you can also get only the extension p1.suffix. So that's the third output. If you were working with a string to represent the path, you could still do these things, of course, but it is more work and the code is less elegant. So that was a path to a file, but you could also have paths to a folder, so a directory, like path, and you could say just files, and that points us to that files directory. And if you want to print out the list of files and directories inside files, you could do print p2.iterdir. Call that method and run. And you'll see that the output is a generator. So it has those file names inside, but you want to extract them somehow. And you could do the extraction either with a for loop, like for item in p2.iterdir print item. So that's one way to extract those file paths. And if you're curious to print the type of those items, you could do that. And you'll see that these two are path objects. So there is consistency for good reason. Even the objects generated by other methods, such as this one in here, are also path object types. So P2 is a path object type, so-called POSIX path, and also the output of this was a generator containing multiple path object types. Right, so that was one way. You could also convert this into a list, this generator. Execute, and you get these path objects printed out inside this list. You see the square bracket here, the closing square bracket in there. So that's what you need to know for now. I think this gave you a good idea of what Pathlib is about. But you will learn it better as we use it in many programs that we will build throughout this section with real world examples. So I'll talk to you later. Thanks.